A homeowner is interested in a whole home backup generator. What's the fastest and most accurate way to figure out what size of generator they'll need?
You can do better than just guessing or looking at the service size. The right way, and the code-compliant way, is to size the generator based on an NEC-compliant load calculation.
In this video, we'll show you how to size a residential generator in just a few minutes using our load calculator. The tool follows NEC Article 220, so you'll get clear, defensible load calculation that will result in a better generator sizing with fewer callbacks and smoother approvals from inspectors and utilities. A professional generator size estimate is also helpful in a lot of other scenarios. Because it's so quick, you can add it onto any load calc that you're doing to provide more value to your customer and help drive sales down the line.
With hurricane season in full swing, more homeowners are looking for backup power. Especially in states like Florida, Texas, and the Carolinas, a standby generator can mean the difference between staying safe and going dark.
The data backs this up. From January to September 2024, the US experienced 1.2 billion hours of power outages, especially in storm-prone regions, and generator installs are way up. Generac saw a 28% bump in residential generator revenue year over year.
More homeowners are planning ahead, and that means more demand for fast, code-compliant generator sizing.
Today, we're helping a homeowner in coastal North Carolina who's looking to get through storm season by adding a whole home generator with an automatic transfer switch.
Because they want an automatic transfer switch, NEC 702.4 applies. This states that when an automatic transfer equipment or automatic load connection is used, the standby source shall be capable of supplying the full load that is transferred. This means the generator needs to handle the full load of the house as calculated by an approved method like an Article 220 load calc.
So let's build a load calc to figure out exactly what size generator they'll need.
First, we'll plug in the address for this customer.
From this address, our calculator automatically pulls in the home's square footage. In this case, the home is just over 1,200 square feet. For general lighting and general use receptacles, the NEC requires 3 volt amps per square foot, which gives us 3630 VA right off the bat for baseline load. Now let's add our small appliance circuits. There's 4 of them, totaling 6,000 VA, along with the laundry circuit.
Next is HVAC. This home has a heat pump that handles both heating and cooling. Since the same equipment is used for both heating and cooling, we'll enter it into both categories. If there are differences between the heating and cooling loads, the calculator will choose what to include automatically.
Now we move on to our major appliances. We've got a 1,200 VA dishwasher, a 5,000 VA dryer, as well as a pretty normal range hood, microwave, disposal, and a few smaller other items, and we'll enter those here. We don't need to put in every small appliance because those loads are already covered by the general lighting and receptacle loads we put in earlier.
Once everything is in, the calculator handles the demand factors and reductions from NEC 220.83. Since this is an existing dwelling, not new construction, the calculator will automatically take the first 8,000 VA at 100% and the remainder at 40%.
Now with all of that applied, the total adjusted load comes out to 87 amps, and this represents the full load of the house.
To do generator sizing, we'll now click the generator sizing toggle at the bottom of the load calculator.
This opens up 2 inputs, where you get to set the reserve margin percentage and the maximum voltage dip.
The reserve margin helps you convert from the load calc VA value to a generator size recommendation. A margin of 10 to 20% is typical to account for general growth and safety, but you may want to adjust it based on the needs of your customer.
For example, if you feel that the load calc is conservative, as it might be for larger homes due to the fixed 3 volt amps per square foot lighting load, you might choose a smaller margin. On the other hand, homes with a lot of motors may need a larger margin. Motors draw significantly more power at startup, and you'll want to be sure you're covering those startup surges.
If the homeowner plans to add more appliances in the future, that's another reason to use a larger margin. This home has a relatively normal amount of electrical load. For homes with EV chargers or other large loads, consider load shedding or load management to avoid oversizing the generator.
Now there's the maximum voltage dip, which lets you specify how much of a voltage drop you're willing to tolerate at peak load. For this project, we'll stick to the standard residential voltage dip requirement of 30%.
With a 15% reserve margin applied, our running load comes out to 24 kVA, which you can use to choose which generator will be suitable. In most cases, you can convert kVA to kilowatts directly, since residential generators are often rated at a power factor of 1. That said, it's not always guaranteed, so it's always worth checking the manufacturer's specs if you're recommending a specific model. You can use the notes field to record any sizing decisions or context.
Now all we need to do is click Save and View to generate the final PDF. And on the second page of this PDF, you'll see the generator sizing information.
Everything's clearly laid out. Total load, recommended reserve margin, max voltage dip, and the running VA with reserve margin. It's all right there in the output PDF, ready for permitting, proposals, or handoff to the customer. If you're working on a generator install, a quick load calc can save you time and help you avoid surprises later. It's the simplest way to make sure the system is sized correctly and up to code. You can check out our calculator at Kopperfield.com for fast and simple generator sizing and create a free account to try it for yourself. And if this was helpful, don't forget to like and subscribe. We've got more videos coming with practical tips for electrical design and permitting.